Here's an example from 4.1, but not from our textbook. So we have a table of verbal and math scores for 6 freshmen. So consider this to be paired data. Each verbal score X is matched with a math score Y. And we're going to start by drawing a scatter plot. We'll just do it by hand. And we are told here to use verbal scores across the bottom, at least in my example, and math scores vertically. So looking at those verbal scores, I see the lowest score is 316 and the highest is 653. So I'm going to label my score, my x-axis, as verbal scores, because those are the x ones. And I'm going to label by hundreds, starting at 300. And then I'm going to go all the way up to 700, and that will be able, so that way I'll be able to include all the data values. And it looks like the same labels for the y-axis, which will be the math scores. So I'll label the y value, the y-axis math, and again label from 300 by hundreds up to 700. And I'm doing an okay job. Do your best at labeling. The label should be equally spaced. That'll make our graph more reliable if you put a little effort into the graph. Anyway, I'm going to draw a dot for each data pair. So 428 for an x value needs to be matched with 373 for a y value. We'll just do our best to put a dot somewhere. 386 for an x value, more than halfway, needs to be matched with 571, pretty close to 600. 653 for an x value, pretty much halfway between 600 and 700, needs to be matched with 686, pretty close to 700. Do your best. And then 316 is matched with 319. Both of those numbers are just a little over 300. 438, less than halfway, matched with 607, pretty much right there at 600. And then 323 matched with 440. So that's almost halfway between 400 and 500. So something like that might be our scatter plot, and that's going to be good enough, right? Then based on the scatter plot, I might, if I squint at it, I do see a positive trend. I kind of see the data going up overall as we move to the right. So I'm going to say that this is positive. And whether it's linear or not, hard to say. If you want to rate it strong or weak, it looks fairly strong to me. I'm going to put it down with a question mark just based on my graph. It really is hard to tell. Super strong is easy, super weak is easy, but the middle graphs are hard. All right, now calculating R, we're going to enter the values into L1, X. The X values go into L1 and the Y values go into L2 like we've practiced. And then remember that the lin/reg AX plus B, that's in the stat button and moving over to the calc area. And then find lin/reg AX plus B, find those instructions up above, follow that. And I got R equals 0.750, rounding to 3 places. So based on this value of R, since 0.75 is greater than 0.7, so thinking about that number line that I talked about, so the number line, 0 in the middle, 1 and -1 at the extremes, if we are closer over to than 0.7, either on the positive side or it could have been on the negative side, right? These little areas that are close to 1 and close to -1, those are the strong correlations. So in fact, we are in that area, 0.75, so we have a strong linear correlation. And we can add in the positive there as well. The R being positive does show that. All right, that's our basic example for 4.1. And I've got this caution that's also in Canvas. Our work here is only about recognizing patterns. There's no implication of causality. We don't quite get to say that the math scores are caused by or not caused by the verbal scores, only that there is a strong, in this case, strong or weak correlation in other places. All right, that's 4.1.